This is my look of disapproval. Hello, time travelers. Remember, if you wanted to have regularization data so that you can train a LoRa for SDXL, you had to take the smaller pictures and upscale them? We don't have to anymore. Well, tobecwb, whatever, he made SDXL regularization data. That's why I did the look of disapproval at the beginning of the video before I said anything, because this is my look of approval. Here's an example where I trained using my regularization data process that I showed you how to do in the SDXL training video. You can click the card here if you want to see that. And then I did the same training parameters exactly, except using this new regularization data. So look how Kristen Ritter's eyes are kind of jacked up in some of these. And like the first one down here looks really good compared to this one. Then if we go all the way to the right, looks really good here versus my other generation. As I've explained in previous videos, lots of stuff goes into training a LoRa or an embedding, and a lot more for a LoRa. And every little thing changes the results. And I can already tell that using this regularization data bumps me up just one more notch better. And if you're new to the channel and you weren't aware, but when SDXL came out, Koya, within a few weeks, was able to support training SDXL LoRa's. But I had this whole process where I took the SD 2.1 images, which I'm about to show you, are all 768 by 768, and upscaled them using Stable Diffusion Extras tab so that you would have images that were 1024 by 1024, and mine I put in a folder so I know that I did them for future reference. Now here's the new regularization data from the GitHub repo. Obviously I've linked it in the descriptables below. It comes with an SDXL folder. Once it downloads, I go in here, and see it's 1024 by 1024. All right, let's look at some more examples of testing I've done to validate that this regularization data is needed. For all of these, I trained a brand new SDXL LoRa using my upscaled regularization data, and another separate LoRa using the new regularization data that tobecwb made. Tobecwb made. In all of them, I did 5 random seeds in the testing. Check out these Kat Dennings tests from the first one. It looks good, but with the new regularization data, it looks even better. And here's some stylizing that I did with April Balby. She's an actress that's on a show, Doom Patrol, that I watched recently. Again, even though I'm stylizing, which in a sort of painting style, it should hide most of it, but look at the third generation here. It's just slightly better. And look at this fifth one. It's a little bit less darkness around the eyes, a little bit less of that uncanny valley stuff going on that AI tends to do sometimes. Here's another actress from the show Doom Patrol, Diane Guerrero. I can't say people's names. Like number 3, the new regularization data looks way better, and also number 5. Looks more like her. Here's some more stylized stuff with a different, completely random actress. This is Elizabeth Hurley. Look at how the eyes and the cheeks look in this generation versus the old regularization data that I had to upscale. For the viewers that already know how to train for SDXL using regularization data, you can skip to the next chapter if you want. If you know how to train a LoRa, but not for SDXL, then click the card for the video above that I've already mentioned earlier and watch that after you're done watching this video. If you've never trained a LoRa before, or you've never done it with regularization data, start with my first LoRa training video, which you'll find linked in the descriptor below. All my LoRa training videos are down there. And you should subscribe because I've been teaching myself a little bit about SDXL Turbo and doing a lot of testing with that. Imagine doing SDXL in seconds instead of minutes. So I'm definitely going to be doing a video on that soon. And another good reason to subscribe is because sometimes I do skits. And I recently shot a few skits where I've used AI to help me not only do the writing for the script, as well as put some elements into the video that you might not expect. So definitely look forward to seeing those. Now I need to show you how to download the regularization data because it's freaking huge. So here at the repo, you would expect to be able to hit code in the download zip. Don't do that because it'll freaking time out. You hit this little copy button, next to the URL. If you've ever done a git clone before, that's what we're doing. Whatever method you choose to open command line in here, a lot of YouTubers will say type CMD up here and then hit enter, but that screws it up for me when I want to hit back and forward up here. It doesn't work anymore. Well, since I have this plugin over here, I'm going to hit that and open it. And there, it's in the right folder. But if you don't have a plugin like that, you hit Windows button R on your keyboard and then type CMD in the run box and hit enter. Once this is open, move it down so you can see the address bar over here of where you were in that folder. Copy it. Go over here and put CD. And just in case, like for my case, I have to change from drive C to drive D /D. This /D does not mean change drive D. This means change the drive. And then I type in a double quote and hit paste and another double quote. And there, I'm in the right folder. You can double check these are the same. Now you want to type git clone. Go back to the GitHub page, copy this thing because I had overwritten my clipboard by doing the other thing a second ago. And then don't hit enter if you have something with this folder name right here already in this folder. Let me show you what I mean. Here's the folder, and I already have a folder with that name here. So what I had done is I hit F2 on this and hit Control C to copy it, and then type the space over here, and then right click to paste, and then I erased a main and typed a new. But I'm going to go ahead and type example at the end so you can see what happens once you do this. So the command is git clone, and then there's the URL to the repo. And then over here, all of this is the folder you want to name it as. So normally when you git clone, you don't do this last part. And then just hit enter. I have to enter twice because I clicked it, but anyways. It says cloning 2. And why this works and doesn't time out because it's so many gigs of data is because it's iterating through all the files on the repo and does each one at a time. Since I've already downloaded it, and by the way, this takes a while, go walk away, live your life.
YOLO, live your life and don't think about it.
Make a sandwich and eat it, check the mail, do laundry, have an epic poop, I don't care. And then come back. But I'm going to hit Control C because I already have this data and it's going to cancel that. Once you have the data, we're going to do it to the man data. Because I've already done it to the woman training folder. Just hit F2 to rename it and then go to the end and hit dash training folder. The name of this particular folder doesn't matter except that I need to remember what's in there and what I've done in there. So open that folder up and then I'm going to change to this folder. CD/D space double quote paste double quote again, and then I'm going to type makedir 1_man. And the reason is because LoRa training determines the number of repeats that it does for the images inside the folder off of the number that appears before the underscore in the folder name. And hit enter. All right, now you see I've got this folder here and I've got all these images, and they're all JPEGs. Now back to the command line folder, I'm going to type move star.jpg 1_man. Enter. It only takes a moment to move all those files. And if you change your mind and you don't want your folder that way, you can always move the files back. But in your case, you're going to be doing one woman if you're doing a woman training or whatever, because he's got man and woman. So now these are both done. And now that's it. That's all you have to do with that. So thanks for watching this quick video about regularization data. This guy, I had mentioned him in my previous videos, and he's pretty cool that he was able to make these for us. And all I had to do was ask him. It took him a few months, but you know, we all have lives to live. We all have stuff to do like make sandwiches and have epic poops. If you still don't know how to use Stable Diffusion to generate images, click this video. If you want to know some tricks and tips about Stable Diffusion, click this video. And click over here to subscribe to the channel. And I'm going to see you next time. Bye.